So let us consider problem number 2. A solid shaft 5 meter long is stressed at 80 megapascal when twisted to 4 degrees using G is equals to 83 gigapascal. Compute the shaft diameter. What power can be transmitted by the shaft at 20 Hz? So for this example, so given yung mga values natin for yung we have a length. So sulat muna natin yung mga given natin. So the value of our length, that is 5 meter. The value of your angle of twist is 4 degrees. It's 4 degrees. And the value of your stress at 80 megapascal. The value of your stress, so ito yung maximum natin, which is equal to 80 megapascal. And yung value naman ng F natin, o yung frequency natin, that is 20 Hz. So, kino-compute natin, dito hinahanap natin, yung nire-require sa problem natin, is the value of your diameter and the value of your power. So for this one, we talk first for the value of your diameter. So in computing for the value of your angle of twist, that is equal to tulo laway over JG. So angle of twist, that is tulo laway over JG. So, we have an angle of twist. So, that must be in terms of radians. So, in using this formula, laging naka-radians po at dapat laging in radian. So, gagawin natin yan is we're going to multiply pi over 180 degrees para maging radians siya. All over the value of your t, hindi natin alam yung value niyan. Yung 5 natin, ito yung length natin. So, gagawin natin siyang mm. Kaya nga, meron tayong i-multiply sa kanya na 1,000. All over, yung value ng J natin, yun yung hinahanap natin. So, etong D natin is in terms of meter siya. So, we have pi d raised to the 4th all over 32. Yun yung J natin. Multiplied by the G natin, which is naka 83 gigapascal, wherein yung G natin is equal yan sa 83 times 10 raised to 9 pascal. So, kapag inano natin yan ng megapascal, so G is equals to, eto nyan, mangyayari lang naman yan, 83 times 10 raised to 3 megapascal. Okay? So, kung anuhin naman natin yan into kPa, so G is equals to 83 times 10 raised to 6 kilopascal. So, for this one, yung kapag gigapascal to megapascal, nagta-times lang tayo by 3. So, we have 83 times 10 raised to 3 Newton per mm squared or megapascal. So, yung torque natin yan, yung ilalagay natin dyan, so kung isi-simplify natin yan ng buo, so we will have 0.1138 d raised to the 4th. So, eto, nakuha natin yung T natin in terms of D. So, susunod naman, gamitin naman natin yung formula natin for the maximum torsional stress, which is equal to 16T all over pi d cubed. So for this one, the value of your maximum torsional stress is equals to 80 megapascal is equals to 16 T all over pi d cubed. So in terms of T, yung T natin dyan, that is equal to Meron tayong value ng t. So, 16. So, yung t natin, that is equal to 0.1138 d raised to the fourth all over pi d cubed. So, makukuha na natin yung value ng d natin. Kasi yung mangyayari dyan is makakancel lang naman yung 3 natin. So, magiging 1 na lang yan. So, yung value ng d natin, that is equal to 138 mm. So, this is our answer. So, next naman is the value of your power. So, whenever we have a twisting effect, so yun nangyayari sa material natin, nagkakaroon tayo ng power. So, due to the torsional stresses, yung nangyayari sa mga material natin, it transmit a power. So, meron tayong formula in computing for the value of your power sa mga shaft natin, considering yung torsional effect natin. So, for this one, the value of your power, or the power transmitted by the shaft, which is denoted by P, is equals to T, or the torque itself, multiplied by yung angular velocity natin. So, yung W natin dyan, that is yung angular velocity natin in radians per second. So, kung aayusin natin yan, yung value ng W kasi natin, ito in radians per second to ha. So, yung tendency sa isang second, radians per second, ito yung number of rotations natin in radians per second. So, yung tendency, so kapag naikot niya yung isang bilog, that is equivalent to 360 degrees, or which is equal to, in radians, that is equals to 2 pi. Tama? So, isang bilog, isang ikot, 1. So, ilang beses siyang iikot, so that is yung F natin. So, yung value ng W natin, that is equals to 2 pi F, o yung frequency natin. So, for this one, ilalagay natin dito sa formula, so that will become 2 pi F multiplied by T, or equal to 2 pi Pf. Wherein yung F natin, that is number of revolution per second. So, kung ilang beses siyang iikot dito sa shaft natin. So, let us use this formula to solve for our. So, yung power natin is in terms of watts to. So, for this one, let us solve for the value of your power. So, P is equals to, as indicated, ito yan, 2 pi Tf. Kaso, in terms of torque, kung aayusin natin yan, torque is equals to pi to power all over 2 pi F. So, for this one, the value of your T, that is equal to 0.1138 d raised to the fourth is equals to P all over 2 pi yung hertz natin, or the revolution per second, which is equal to 20. So, the value of your P in terms of D, that is equal to 14.3 d raised to the fourth. So, kung ilalagay natin yung nakuha nating value ng D natin, so which is 138 raised to the fourth. So, the value of your P, so that is equal to 5186237,285 Newton. So, mangyayari kasi dyan, that is Newton in millimeter. Newton in millimeter per second. So, kung equivalent natin yan into watts, so, mangyayari is i-divide natin yan by 1,000 para maging Newton meter per second. So, i-divide natin to by 1,000. Kasi 1 Newton meter per second, that is equivalent to 1 watts. So, for this one, yung mm, gagawin natin yan kasi naka-mm to. So, yung mm na yan, gagawin natin yan into meter. So, kaya 1 Newton meter second equals to 1 watts. So, yung mangyayari, the power of your shaft, that is equal to 5186237.285 watts. Kung in terms of megawatts natin yan, so we have 5.19 megawatts. Or yung mega natin, that is equal to times 10 raised to 6. 5.19 times 10 raised to 6 watts. So that is yung formula natin. And that is our procedure in computing for the value of your power in shaft. So ganun lang kadali yung pagkuha natin, pagkukonsider natin sa mga torsional shearing stress.